Download this code from codegive.com, link in the description below. Easy Attribute-Based Access Control, abac, for GraphQL APIs. Attribute-Based Access Control, abac, is a powerful authorization model that allows you to control access to your GraphQL API based on attributes associated with the subject, user, the resource, data, the action, query/mutation, and the environment, time, IP address, etc. This provides a fine-grained and flexible approach compared to simpler role-based access control, rbac. This tutorial will guide you through implementing a practical abac system for your GraphQL API using a combination of libraries and techniques. We'll focus on a lightweight and easy-to-understand approach suitable for many projects. We'll use Python for this example, along with popular libraries like Graphene for GraphQL implementation. The principles, however, are applicable to other languages and GraphQL frameworks. Prerequisites ****. Basic understanding of GraphQL. ** familiarity with Python and its package manager, pip. ** an existing GraphQL API, or a willingness to create a basic one for this tutorial. * will assume you have Graphene and Graphql installed. You can install them via pip. 1. Conceptual overview. Before diving into the code, let's outline the key components and the flow of our abac system. Subject, user represents the entity attempting to access the GraphQL API. This will typically be your authenticated user, and the subject carries attributes such as user ID, roles, department, etc. Resource, data, the specific GraphQL data being accessed, example a product object, a user object. Resources will also have attributes, such as product category, privacy settings, owner, etc. Action, the operation being performed, example read, create, update, delete. In GraphQL, this maps to queries and mutations. Environment, contextual information like the current time, client IP address, or any other situational data. Policy, a set of rules that define whether a subject is allowed to perform a specific action on a resource under a certain environment, based on their attributes. Policies are the heart of abac. A policy might say, users in the admin department can update any product, but only if the current time is during business hours. Policy enforcement point, PEP, the component responsible for intercepting requests and evaluating policies to decide whether to grant or deny access. This is where our authorization logic will reside. Policy decision point, PDP, the component that makes the access decision based on the policies and the attributes of the subject, resource, action, and environment. In this simplified example, we will embed the PDP logic within the PEP. 2. Building a basic GraphQL API, example. Let's start with a simple GraphQL API for managing products. This API will have a product type with ID, name, category, and owner_ID fields. We'll provide a query to retrieve a product by ID and a mutation to update a product. 3. Implementing the abac authorization logic. Now, let's add the abac authorization logic. We'll create helper functions to manage the subject, resource, action, and policies. 4. Applying the abac authorization to resolvers. Now, we'll apply the authorized decorator to our GraphQL resolvers. This ensures that every request goes through the abac policy evaluation. 5. Testing the abac implementation. Now, let's test our abac implementation with different scenarios. Explanation *. Asterisk we defined get_subject to retrieve user information. In a real application, this would pull the user from the authentication context, example from a JWT token. Asterisk get_resource_attributes extracts the relevant attributes from the product object. Asterisk evaluate_policy contains rbac policies. This function determines whether a given subject is authorized to perform the action on the resource. Asterisk the authorized decorator wraps the resolver functions. It calls get_subject, get_resource_attributes, and evaluate_policy to enforce the access control. Asterisk if access is denied, an exception is raised, preventing the resolver from executing. 6. Key improvements and considerations. This is a simplified example, and there are many ways to improve and expand upon it. Asterisk policy storage asterisk instead of hard-coding policies in evaluate_policy, store them in a database or configuration file. This allows for easier management and dynamic updates. You could use JSON or YAML files for simple policy definitions or a more sophisticated database for complex rules. Asterisk external policy decision point, PDP consider using an external PDP service, example Open Policy Agent, OPA, for more complex policy evaluation. This decouples the policy logic from your application code. Asterisk attribute retrieval asterisk implement more robust mechanisms for retrieving subject and resource attributes. For subjects, integrate with your authentication system, example OAuth 2.0, JWT. For resources, fetch the attributes from the database. Asterisk error handling asterisk provide more informative error messages when authorization fails. Consider returning a custom GraphQL error type instead of a generic exception. Asterisk performance asterisk for complex policies or high traffic APIs, optimize the evaluate_policy function. Caching policy decisions can significantly improve performance. Asterisk testing asterisk write comprehensive unit tests to ensure your abac policies are working correctly. Test different scenarios with various subjects, resources, and actions. Asterisk environment attributes asterisk incorporate environment attributes, example current time, IP address, into your policies. Asterisk policy administration asterisk develop a user interface or API for managing abac policies. Asterisk logging and auditing asterisk log authorization decisions for auditing and debugging purposes. 7. Example, using Open Policy Agent, OPA, as a PDP. Open Policy Agent, OPA, is a powerful open-source policy engine that can be used as an external PDP. Here's a basic example of integrating OPA with our GraphQL API. 1. Install OPA asterisk follow the instructions on the OPA website to install and run OPA. 2. Define a policy in Rego, Opus policy language. Create a file named policy.rego with the following content, example. 3. Load the policy into OPA asterisk use the OPA CLI to load the policy. 4. Update the evaluate_policy function asterisk modify the evaluate_policy function to query OPA. Explanation of the OPA integration asterisk. Asterisk the evaluate_policy function now makes an HTTP request to the OPA endpoint. Asterisk the request body contains the subject, resource, and action as input to the policy. Asterisk OPA evaluates the policy based on the input and returns a JSON response indicating whether access is allowed or denied. Asterisk the evaluate_policy function parses the JSON response and returns true, allow, or false, deny. This example demonstrates how you can offload policy evaluation to OPA, making your abac system more scalable and maintainable. Conclusion **. This tutorial has provided a practical introduction to implementing abac for your GraphQL API. By following these steps, you can create a fine-grained and flexible authorization system that meets the security requirements of your application. Remember to adapt and extend this example to fit your specific needs and to continuously improve your abac policies as your application evolves. Using abac will significantly enhance the security and control over your GraphQL data. Good luck.